Hi guys, welcome to my video. In this video, I will be going over the basics of creating arrays in Numpy. So, first thing we want to do is import Numpy as NP. This is a common convention for importing Numpy in the data science world. So, first thing we're going to do is run this, and then we want to create our first Numpy array. Array1 equals np.array 1, 4, 3, 2, 5. You pretty much just use a list inside of the array function. When you run that, it should give you that list output as an array. And so next we're going to do array2 equals np.array 3.14.237. So we're going to run this, and this does something called upcasting. So 3.14, 2 point, 3 point, and 7 point. These were all upcast from 2, 3, and 7 because all the values inside of the array must contain all elements of the same data type. So next, what we can do is we can do datatype manipulation. So we can take that NP array and on array2, and you convert the data type to int16, which is going to convert all these to integers. And when you convert 3.14 to an integer, it cuts off the float portion. So it just goes to 3. np.array of array2, and now we can convert it to a float, and it will convert all the values to floats. So next, what we want to do is create a two-dimensional array with all zeros. We use np.zeros and run that. It gives you two rows by 10 columns, all zeros. np.zeros, 2 rows, 10 columns. Rows, columns, rows, columns. Remember that. So np.ones is going to give us all ones, 3 rows by 5 columns. There you have it. 3 rows, 5 columns. So now np.full is going to give us 3 rows and 5 columns of whatever value we put in here. So we're going to run it, and it's going to give us a full array of 3 rows by 5 columns of 3.14. If we change this value to 3.2, it's going to give us all values of 3.2. So next, we're going to do np.arrange 0 to 20 by 2s. So what it's going to do is it's going to create an array filled with a linear sequence going from 0 to 20, and it's going to step by 2. So it's similar to the range function in Python. So 0, 2, 4, 6, 8, 10, all the way up to 18 because it goes up to 20 but not including 20. If you go to 21, watch, you have 20. There you have it. So next we can create an array of 5 values evenly spaced between 0 and 1. So linspace, which means you're going to have 5 values here. This is the number of values between what range? Between 0 and 1. So we're going to run that. It's going to give us 0, 0.25, 0.5, 1. If we change this to 2, it's going to give us something similar, but 0, 0.5, 1, 1.5, 2. So next, we can create a 3 by 3 array of uniformly distributed random values between 0 and 1. So we're going to run this, and it was 3, and they're uniformly distributed. So if you go through and you do data analysis functions, you'll find out that they're uniformly distributed. They're random values though. So now we create a 3 by 3 array of normally distributed random values with a mean of 0 and a standard deviation of 1. So what we do is np.random.normal, 0 as the mean, 1 as the standard deviation, and it's a 3 by 3 array. So we're going to run that, and you're going to get the array, and you'll find out if you do the average on these, it will be 0. And then, well, the mean of those values will be 0. And the standard deviation will be 1. Next, we're going to do np.random.randint 0, 10. So it's going to give you random integers in a 3 by 3 array between 0 and 10. So we're going to run that and watch 785, 636, or 825. If you run it again, it'll give you new random values, but they'll stay between 0 and 10. Whoopsie. So next we want to create a 3 by 3 identity matrix, np.I, which is going to be an identity matrix. So it's going to be 3 ones across the diagonal. And there you have that 1, 1, and 1. It's an identity matrix. So any other 3 by 3 matrix multiplied by this 3 by 3 matrix will give you that other 3 by 3 matrix. Simple linear algebra. So next, you have an uninitialized array. So this is going to give us values that are already existing at a specific memory location. And when you run this, it'll give you 1, 1, and 1 floats. Thanks for watching my video. Please consider subscribing. That's all for today.